Okay, let's try problem 6.53. A car drives over the top of a hill that has a radius of 50 meters. What maximum speed can the car have without flying off the road at the top of the hill? Okay, so let's just draw a picture. So I'm just going to draw a circle first. Then let's say that the hill looks something like this. I'll circle for a little bit. Okay. So we know that the hill has a radius of 50 meters. So from the center of the circle up to here is 50 meters. And we're looking for the maximum speed that the car can have without flying off the road. So let's put our car up here. And it's traveling this way, Vmax. Looking for Vmax. Oh, probably can't see that. Vmax. Okay. So that's the first thing we should do is just draw a free body diagram. So here's the car. So the car is going to have its weight. It's also going to have a normal force. And so the centripetal acceleration is going to be keeping this, the centripetal force is going to be keeping this car moving in the circle over the hill. So we know that F net is going to be equal to centripetal force, which is equal to mv squared over r. And we know that the net force on here is just going to be W minus n. Okay, so now why is it W minus n if W is pointed this way? So our centripetal force is going to be pointing towards the center of the circle, right? Which is going to be in the same direction as our weight. But our normal force is going to be pointing upwards, which is in the opposite direction. So that makes our weight, which is in the same direction as the centripetal force, positive, and our normal force negative since it's in the opposite direction. Okay. So another thing that we're looking at here as well is that we're looking for the maximum speed that the car can have without flying off the road. So as soon as it flies off the road, that moment when it loses contact with the road, that means that the normal force, right, this right here, the normal force has to be 0 at that point because it's no longer in contact with the road. And so we want to find that exact moment when the car loses contact with the road. So by setting the normal force equal to 0, which means that the tires are no longer connected to the road at that specific time, the specific moment, then we can find the maximum speed. So let's just go ahead and do that. So mv squared over r is just going to be equal to w now, right? Because we said that n is going to be equal to 0. And so mv squared over r is going to be equal to w, or w is just the same thing as mg. So these masses are going to cancel out. And rearranging this, we get v squared is equal to r times g, or v is equal to the square root of rg. And now we know the radius and we know gravity, so we can just plug this in, and this comes out to 22 meters per second. And that's problem 6.53.